the two properties which are important, initial value theorem and final value theorem. Later we will go to the transform analysis. Okay. So, initial value and final value theorem.
Sir,
Yeah.
sir, homework problem explain ಮಾಡಿ sir.
Which one? Homework problem.
Sir, ನೆನ್ನೆ ಕೊಟ್ಟಿದ್ದಾರೆ.
Yeah, which one I gave? Just remind me. Inverse the transform, right?
Sir. Sir.
Okay. Eight z square, right? That one. Numerator 8z square plus 4z. Is it that one? Hello? Hello?
So z square minus 3z by
divided by z square plus 3z by 3 by 2 into z minus 1.
Okay. Just tell me once again. 1 plus.
So z square by z square minus 3z.
1 minute. 1 minute. Z square minus 3z.
Divide by.
Okay.
Z square plus 3 by 2 into z.
Z square plus 3 by 2 into z.
Minus 1.
Minus 1. Okay. So this is x of z which is given. So now we need to find out the inverse z transform, right? Okay. So the ROC which I gave, is it the value which is 1 by 2 less than z less than 2? Is it the ROC same which is given?
Same.
Okay. So now we can directly find out the roots of this, or we can put it in inverse form and then we can do it also. Okay. Now if I multiply both numerator and denominator by z power minus 2, okay, so we will going to get 1 minus 3 into z power minus 1 divided by 1 plus 3 by 2 into z inverse minus z power minus 2. Okay. So this is what you will going to get in the inverse z transform. Now we can find out the roots. Okay. So what is the product we need to get? Product we need to get which is minus 1, because here the coefficient is minus 1 and this one is plus 1. 1 into minus 1 into plus 1 is 1. The product should be 1. The addition should be plus 3 by 2. Now if I take the roots 2 and minus 1 by 2, what will happen? This product, it should be equal to minus 1, and if I add this one, we will going to get 2 minus 1 by 2 which is equal to 3 by 2. So the same thing we are getting here. Is it clear this one, how to find out the roots? Now I took 2 and minus 1 by 2 as the roots. Okay. Or even we can also you can put that the formula, you know, that minus b plus or minus square root of b square minus 4ac divided by 2a. This formula you know, right, for the finding out the roots. Even you can put this and you can able to find out the roots. Okay. That is also possible. So now if I put that roots, so we will going to get 1 minus 3 z inverse divided by 1 plus. So in order to get plus, here plus 2 z inverse I need to put, and here minus half z inverse I need to put, minus z power minus 2. Okay. So this will give, so 1 minus 3 z inverse divided by, so you can here you can take the common factor which is 1 itself. Okay. So you can put 1 plus 2 z inverse, or 1 into 1 plus 2 z inverse, and then you can put the, here you can take the common minus 1 by 2 if I take minus 1 by 2, here it will be, so z inverse minus what will be, if I take minus 2, it will give plus 2 z inverse. So I'll take half minus z inverse, so that you will get here 1. So 1 plus 2 z inverse. Okay. So here half 1 by 2 into z inverse here. So 1 minus 3 z inverse divided by, now we can take in again these two terms which will common is 1 plus 2 z inverse into, so remaining term is 1 here and 1 minus minus 1 by 2 z inverse, that is 1 by 1 minus 1 by 2 z inverse. So this is common in both these two factors. So this if I take out, remaining term is 1 minus 1 by 2 z inverse. So now this is what we will going to get x of z after finding out the roots for this. Okay. Now you use the partial fraction method. Okay. So we can take a by 1 plus 2 z inverse and then plus b by 1 minus 1 by 2 z inverse. Now equate it and take the LCM and cancel each other both right and left side. Find out the coefficients of a and b. So can you find out now? So we will going to get 1 minus 3 z inverse, which is equal to, so a minus half z inverse into a plus b plus 2 z inverse into b. So now the coefficient of 1, so if you are taking a real values, so or z power 0 coefficients if we equate, you will going to get a plus b. So this and this, it will be equated to 1. This is one equation, and z inverse, so coefficient is minus half into a and here 2 into b. Okay, minus half into a plus 2 into b, which is equal to minus 3. So this is what second equation. Okay. So now, so these two equations you can solve and get the values of a and b. Okay. That is a plus b, which is equal to 1 minus half a plus 2b, which is equal to minus 3. Now I will multiply this equation by 2 and then subtracting, so equation 1 by 2. So you will going to get this one, so 2a plus 2b, which is equal to 2, and here minus 1 by 2a plus 2b, which is equal to minus 3. Now I will subtract it, this equation and this equation, you will going to get, so what is the value? 2 plus 1 by 2. So 2 plus 1 by 2 into a. So this will going to cancel each other, which is equal to 2 plus 3, which is equal to 5. So this will be equal to 5 by 2 into a, which is equal to 5. So this 5 will get cancelled and you will going to get a equal to 2. So did you get this value? Anybody? So now
Yes,
find
sir.
out,
Yes, sir.
yeah, find out the value of b. So b which is equal to 1 minus 2, which is equal to minus 1. So this is what the value of b. So now we can write x of z, which is equal to 2 divided by 1 plus 2 z inverse and minus 1 divided by 1 minus 1 by 2 z inverse. Now corresponding x of n, what we can write? So since it is a left sided sequence, so it will be minus 2 power n, sorry, 2 power n into u of minus n minus 1. Okay. So 2 into 2 power n into u of minus n minus 1. This is left sided sequence for this, and then plus this is right sided sequence, sorry, minus half power n into u of n. So, did you get this one? Hello.
Sir, in this problem, m is equal to n, right? So we should use long division method.
So, where m is equal to n? So, we can see.
So numerator, it's the order is 2 and the denominator the order is 2.
Okay. So, now if I multiply like this, so what will happen? 1 minus 3 z inverse. Now, we can see here. So, if you bring in this form,
Yes, sir.
so is it numerator is greater than the denominator polynomial?
Okay. Yes, sir. Okay.
Is it like that? No, no. Is it not?
Yes, sir.
Ah. So, this is the answer. If you anybody any doubt in this, or if you got this answer?
So x of n is minus 2 into minus 2 power n, sir.
Minus 2 into,
Minus 2 power n.
so minus, okay. So, here it is, we got 2 by 1 plus 2 z inverse. Okay. So, now here we can write this one 1 minus of minus 2 z inverse. Okay. So, this denominator. So, now this we can write it as minus 2 whole power n. Yeah, here it is minus 2. Yeah, so this is minus 2 whole power n, because if you take
Even
the
outside of the room.
if you take the z inverse of left sided, like 2 power n into u of minus n minus 1, let us take minus 2 power n. So, if I take summation n equal to 0 to infinity minus 2 power n, since it is minus 1 to minus infinity. Okay. So, here it is, so 1 into z power minus n. So, like this we can take. Okay. So, now we can combine this, which is minus 2 into z power minus 1 whole power n. So, now if you take this one, summation n equal to minus 1 to minus infinity. Okay. So, now if I change the variable this one, we have n equal to, so if I change the n, okay, n equal to minus k if I take, so k will be equal to 1 to infinity, and wherever n is minus k. So, minus 2 z inverse, so plus value is minus k. Okay. So, now if I take the inverse of this, we will going to get half into z whole power plus k. Okay. And now we can write this one, 1 over, okay, half z divided by 1 minus 1 by 2 z. So, if I want to retain z inverse, so this 2 power minus 1. So, let us do that one. So, then we will come to know that result. So, I will do that. Let us confirm that once. Okay. So, otherwise summation n equal to minus 1 to infinity minus infinity minus 2 power n into 1 into z power minus n. Okay. So, if I take, okay, minus of minus 2 power n, let us take, and now we can get minus summation k equal to 1 to infinity. So, if I substitute n equal to minus k, so k will be equal to 1 to plus infinity, and then minus 2 power minus k into z power plus k. Okay. So, this will be equal to minus k equal to 1 to infinity, and then so this we can write it as minus 2 whole power minus 1 whole power k into z power k. So this inverse if I take, so this will give 1 by 2 minus 1 by 2 power k into z power k, summation k equal to 1 to infinity. So this we can write it as minus, again if I want minus k, because in the standard form k equal to or n equal to 1 to infinity alpha power n, so this will be equal to alpha by 1 minus alpha. This is what we have standard result. So now if you want, so yeah, now power k is there, summation k equal to 1 to infinity 1 by 2 minus 1 by 2 into z whole power k. So this will give minus 1 by minus 1 by 2 k divided by 1 plus 1 by 2 k. So here 1 by 2 k is coming, so this is half into, that is z, sorry z, this one half z divided by 1 plus 1 by 2 z is coming. So instead of 1 by 2 z we want 2 z, so that's why it is, if you put plus minus n, so then you will going to get this one plus k, and here it is plus, again here it will become 2 power k. So then it will be the minus of minus 2 power minus n. So that is what the result we need to get. Okay, so here minus of minus 2 power minus n, so that is what you need to get. So is it correct? Now you are getting, hello, minus 2 of minus 2 power minus n into u of minus n minus 1. So this is what you need to get for this one. Are you getting now? Minus half into half power n into u of n. So this is what the result you will going to get, x of n. Is it understood now? Hello? So if you get, if you put this 2 power minus, if you put 2 power minus of minus 2 power n minus n, so you will going to get that result. Okay, so this is x of n, if it is minus of minus 2 power minus n into u of minus n minus 1, if you put, then you will going to get 1 over 1 plus 2 z inverse, that is okay. So here one more thing, so we need again 2 z inverse here, because we cannot put like this, because here 2 z inverse is not there. Okay, so this also not possible, because 2 z inverse if it is there we can put that, otherwise we cannot put. Okay, so this one what we are going to get, minus n equal to minus 1 to minus infinity minus 2 power minus n into z power minus n. So if I put like that, we are going to get minus k equal to 1 to infinity, so minus 2 power k into z power k. So this will going to give minus k equal to 1 to infinity minus 2z whole power k. So this we can put it as, so minus 2z divided by 1 plus, so minus of minus 2z divided by 1 plus 2z. Okay, So this will give 2z divided by 1 plus 2z. So here the z term is again which is appearing. So here now what we can do in our problem, so here z term is not there, so even we can multiply and divide by z term, and we can put this one as, so okay, 2 power minus n into u of minus n minus 1, that is fine. But again z term, so that we cannot get the inverse Z transform. Okay, so even we can use the property here. So one shifted signal, so if you multiply z and z here, so this we can take it as z power minus 1, and this minus 1 we can shift the signal, whatever x of n which is coming this one, okay, so that we can shift the signal and we can write. Okay, so this z inverse and z if you multiply here, so this complete signal we can write like this. So that is minus 2 power minus 2 power whole power minus n into u of minus n minus 1. So that is what we have derived here. So this if I put here, so this value, and you will going to get this resultant. Okay, so now this resultant wherever n is there, you have to shift minus 1. So that we need to do for this one, z power minus 1 if I multiply here, so into this one, so you will going to get, so the shifted version. So this signal you just multiply by, with the shifted version. So now this x of n, okay, so x of n, so which we can write it as minus 2 into minus 2 power minus n into u of minus n minus 1 minus half power n into u of n. So this is for 2z by z, 1 plus 2z. Okay, now so there is a extra term here. So since there is a extra term which is there, z power minus 1, we need to shift the signal by 1 time. So that is the resultant will be minus 2 power minus 2 minus n minus 1. So that minus 1 will, because of the shifted signal, into u of minus n minus 1 and minus 1. So that will become minus 2, okay, minus half power n into u of n. So this is what you are going to get the result. So have you understood this one? Any doubt in this? How you get this one? Hello? Anybody any doubt? Understood or any queries? Brusal Anwar understood? Gagan Kumar, Rishabh?
Yes, sir.
So that
Yes,
is,
sir.
so that is how we need to do.
You can explain again, sir.
This one?
This one is, sir. In previous step, it was minus n minus 1, sir. N minus.
Yeah, so here what will happen, the resultant or whatever x of z we have, that is 2 by 1 plus
1 plus
2z minus 1 over 1 minus half z inverse, right?
z. Yes, sir.
This is what we have. Okay, so sorry, so here we need to multiply z inverse as well as z in order to get the alpha which is 1 to infinity, right? So that is what here, so for the z inverse is this one which is representing this one. Okay, so now we need to shift the signal by plus 1. So you can you know the property, right? If I have x of n minus n naught, its corresponding z transform will be what? Z power minus n naught into x of z, right? Is it not?
Yes, sir.
So now if I have the input x of n is like, so here it is z power 1 into x of z. Let us treat this as x of z. Okay, z power 1 is there. So now what is the if you come to the reverse point, you will going to get x
X of
of
Z.
n plus 1, n plus 1. So now that means, so wherever n is there, you need to replace n plus 1. So that we need to do. So if I do that, minus 2 minus n, so wherever n is there, you put n plus 1 minus n of n plus 1, u of minus of n plus 1 minus 1. Is it fine? Is it
So now it's
is it
sir.
understood?
Yes,
Now
sir.
minus half power n into u of n.
U of n.
Okay. So now if you write the resultant for this, so now what you will going to get, x of n,
X of n.
which is equal to minus 2 power minus n minus 1 into u of, so here minus n minus 1 and minus, if you add this one, minus 2.
Minus 2. Okay.
So this is what the resultant. Got it? Is it
Yes, sir.
understood or
Yes,
any
sir.
doubt still?
No, sir, understood.
Okay. So this is what the result of this whatever yesterday's problem. Okay. So now we'll do the next one, that is initial value theorem and final value theorem. That is important in exam. It may be asked for 4 marks or 6 marks minimum. Okay. So that is very important. What is actually the importance of this, we will see. Initial value theorem and final value theorem. So what is actually this initial value theorem and final value theorem? If I know the z transform of some signal, that is x of z, okay, only I know x of z, I do not know the time domain signal. So now from this x of z, I can able to find out what is the initial value of the time domain signal. That is what we will call it as initial value theorem. Okay, the initial value of the time domain signal we can able to find out from its z transform by using this equation, that is limit z tends to infinity x of z. Okay, so this will give the actual, so the initial value of the time domain signal. So and this is called as initial value theorem. Okay, so if I know the x of z, okay, so the z transform of the signal, if I want to find out the, so initial value of the its time domain signal, then we can use the equation to find out the initial value, and it is called as initial value theorem. Okay, and similarly if I know the z transform of the signal, and if I want to find out the final value of the time domain signal, that will denote it as x of infinity. Okay, so then we can write that final value equation or final value theorem, which is equal to, so limit z tends to 1 z minus 1 into x of z. So this is what final value theorem. Okay, so even we can prove this. So x of 0, which is equal to limit z tends to infinity x of z, x of infinity equal to limit z tends to 1 z minus 1 into x of z. First we will take the initial value theorem and we will going to prove. Okay. So now for the initial value theorem, so and also one more condition is that, so x of n should be causal. Okay, x of n should be causal. Causal means what? X of n should be equal to 0 for n less than 0. Like left sided, it should be, there should not be any values, only positive sided signal. That is what causal signal we will call it as. Only if the x of n is causal, so then this theorem will be applied. Okay. And even for the final value theorem, so no pole should be outside the unity circle. So that is why this representation z minus 1, why it is coming here means, so no pole should be outside the unity circle, and also there should not be any higher order poles on the unity circle. Okay. So that is what the meaning here, and we will prove this, what is, how to get the initial value theorem, that expression, and how to get the final value theorem. Okay. So now we know, for the proof we know the z transform of x of n. Okay. So that will be equal to x of z, so which is nothing but summation n equal to, so that is minus infinity to plus infinity x of n into z power minus n. Okay. So now, so this I will just expand it. So what I will get, so I will get like x of 0 for n equal to 0. Since it is a causal system, so that is what the condition we have, x of n should be causal. So causal means what? So we can write one more step, it exists from only n equal to 0 to infinity, x of n into z power minus n. So now if I expand this one, what I will get, x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2 plus go on. Okay. So this is what x of z. Now I will take the limit for both sides. Okay. So that limit z tends to infinity both sides, x of z. Okay. So which is equal to limit z tends to infinity x of 0 plus x of 1 into z power minus 1 plus go on. Okay. Now if I substitute the z tends to infinity, so this is 1 over z. So 1 over z means 1 over infinity, that will go to 0. Similarly z square also 1 over infinity square, it will go to 0. So except x of 0, all other term will go to 0. So then we can write x of 0 which is equal to limit z tends to infinity x of z. Okay. So this is what the proof for the initial value theorem. Now if I take an example, so if I know the x of z like this, okay, I know just z transform something like z minus z, z by z minus 1. Okay. So this actually we know the time domain signal, because we have done already the z transform of unit step function, which will give this one. Now if I do not know, that is it unit step or other signal, if I do not know, only I know x of z, that is z transform of the signal. Now if I find out the what is the value, that is initial value of the signal x of 0, then we can apply this one, limit z tends to infinity. So x of z I am substituting z by z minus 1. Now here we can take z outside in the denominator, so we will going to get 1 minus 1 by z. So now if I apply this limit z tends to infinity, so what will happen, this z cancels. So z tends to infinity, if I take 1 over z will become 0. So the value of this total value will become equal to 1. Now we know the for the unit step function the initial value is 1, and even final value is also 1. So that also we can able to check after the proof of final value theorem. Okay. So now we can able to find out the initial value of the time domain signal, which is equal to 1. Okay. So is it understood now here how we can get? Any doubt? Hello? Is it fine? Understood? Sorry, I lost the internet connection. Hello, am I audible?
Yes, sir. You are
Yes,
audible.
sir. Yes, sir.
Yeah, so I lost internet connection. Oh, sorry for that. Is screen visible? Hello.
Sir.
No, sir.
No, sir.
Just wait a minute. I'll leave and join. Sorry for the inconvenience. Okay, so I was discussing about the initial value theorem and final value theorem, and this is a proof. You can see here. So now we can write the z transform of any input signal x of n, which is equal to x of z, okay, and which is equal to summation from n equal to minus infinity to plus infinity x of n into z power minus n. Now the condition which we have told earlier, it is that x of n should be causal signal. Causal means it will only the positive sided, which is equal to n equal to 0 to infinity x of n into z power minus n. Now I can expand this summation, that is x of 0 plus x of 1 into z power minus 1 plus up to go to infinity. So now after this I will take limit z tends to infinity both the sides, so that this will become limit z tends to infinity x of z, which is equal to limit z tends to infinity, and we can apply for this one. Now if I apply the z tends to infinity for this series, so it will be, so wherever z term is there, so this will going to apply. So this is z inverse means 1 over z, so this term. So now if I apply for 1 over z tends to infinity, so this 1 by infinity it will goes to 0, and similarly for all other term also it will go to 0, only we left out with the x of 0. So that is why x of 0, which is equal to limit z tends to infinity x of z. So this is what the proof for initial value theorem. Okay. Now if I take an example, if I know the z transform of some signal x of z, I can able to find out what is the initial value of that time domain signal. Now how to find out? X of 0, which is equal to limit z tends to infinity, so put x of z whatever we know, z by z minus 1. Now I will take in the denominator z common, so which will give 1 minus 1 over z, and numerator z and denominator z will cancel each other, and if I apply z tends to infinity, this will go to 0 and we will left out with the value 1. Okay. So, the initial value of the signal, time domain signal for this particular z transform is 1, and it is true also, because this is nothing but the z transform of the unit step function. The unit step function initial value is 1 only, right, at n equal to 0. So, that proves our theorem, right. So, similarly, the same thing we can apply for final value theorem, and even the final value at infinity of this unit step function is also 1, that we will see whether it will come or not by using the final value theorem. Now, we will see the proof of final value theorem, and we know that so z transform of x of n, which is equal to x of z, which is equal to summation n equal to minus infinity to plus infinity x of n into z power minus n. Okay. So, now I will just shift the signal x of, I will just shift the signal by 1 unit, okay, that is z of x of n plus 1. Now, its corresponding z transform will be, so whatever the shifted value multiplied by the x of z, right. So, this is the shifted one. So, that will be the power will be multiplied by here z power n naught. Okay. So, now this is equation 1 and this is equation 2. So, now subtract 1 minus 2 or 2 minus 1. So, I will take 2 minus 1. If I take 2 minus 1, z transform of x of n plus 1, okay, minus z transform of x of n, which will be equal to x, that is z into x of z minus x of z. Okay. So, now this will be equal to, so if I take x of z common, so we will going to get z minus 1. Okay. And here, so it is z of x of n plus 1 minus z of x of n. Okay. Now, I will take both the sides, limits z, that is z tends to 1. So, take both sides, limit z tends to 1. So, what we will going to get? So, we will going to get, so I will take in the next page. So, limit z tends to 1, z transform of x of n plus 1 minus z transform of x of n, which is equal to limit z tends to 1 z minus 1 into x of z. Okay. So, now I need to get from this the final value of the time domain signal. So, that we know the summation. So, if I take limit z tends to 1, so this I will write the summation. So, the z transform summation, which is n equal to 0 to infinity. So, that because n is the x of n is the causal system, n equal to 0 to infinity x of n plus 1 minus x of n. So, I will take, so together the z transform. Okay. I am taking for both the signal together z transform. Okay. Now, if I expand this one, now if I expand this one, so this right side it will be as it is z minus 1 into x of z. Okay. Now, if I expand this, so you will going to get, so what you will going to get, just you can put the value of n equal to 0 here and then you are go on putting the values, limit z tends to 1. So, if I put n equal to 0, you will get x of 1, okay, minus x of 0. Okay. So, this into z power 0, which will be equal to 1. Okay. So, this will be into 1 again plus, so x of, if I put n equal to 1, so here it will become x of 2 minus x of 1. So, into z power minus 1. Okay. Now, similarly, so we will go on getting the values. So, that will be equal to limit z minus 1 into x of z. Okay, limit z tends to 1. Now, you can see here, so even if I apply the limit z tends to 1, so z power minus 1 is also 1, z power minus 2 is also 1, even so 1 power infinity is also 1. So, that means all the z terms will become equal to 1. Okay. So that we can get x of 1 minus x of 0 plus x of 2 minus x of 1. So, it will go on like this. Okay. Now, we can see x of 1 will get cancelled. Similarly, if you go on putting the series x of 2 and it will go on get cancelled. Finally, we will going to get x of, if I substitute the infinity here. Okay. So, n equal to infinity, you will going to get infinity plus 1 minus x of infinity. Okay. So, now whatever the value you add, so x of 0 and x of infinity, this completely the signal will become infinity. Okay. So, that is how we will going to get the final value, that is x of infinity. So, that x of infinity which is equal to the right sided signal, that is right sided expression z limit z tends to infinity z minus 1 into x of z. So, this is how we will going to get the final value theorem expression. Okay. So, now by using this expression, so as I said, if I know the z transform, like, so now is it understood how the final value theorem got? Hello, anybody, any doubt? Understood? Okay. So, now if I, so the same thing, if I take x of z which is equal to z by z minus 1. Now, if I apply the final value theorem, that is in order to find out x of infinity, limit z tends to 1, okay, z minus 1 into, so now I am substituting x of z which is equal to z by z minus 1. Now, this will get cancel each other. If I apply z tends to 1 for this one, you will going to get value 1. So, x of infinity is also 1. So, that is true for our unit step function. Okay. So, if I go on putting the value at infinity, this is also 1. So, even initial value is also 1 and final value is also 1. That is how we can prove ourselves that initial value theorem expression and final value theorem expression, whatever we have written, is correct. Is it clear? Any doubt? Hello. Is it clear? Skaribano, is it clear? Jahnavi,
Yes, sir.
Pramod. Hello, Pramod. Manoj.
Yes, sir.
Okay, understood. Any clarification, any doubt? Okay, Rakshit,
Yes, sir.
understood?
Yes, sir.
Okay. Okay. So, this is about the initial value theorem and final value theorem. Now, we will move to the next concept, which is called as transform analysis of LTI system. That is, we need to find out the Z transform or transfer function of the system. If the input and output is given, then how to find out the transform of the transfer function of the system. That is, so now if I have, okay, the transform analysis of the LTI system, that is, if I have the input signal x of n, okay, and we have the impulse response and then we have the output. Okay. Now, so this we know the convolution equation, which is x of n into convolve with the h of n, and we will going to get, and we know the Z transform of the, so the convolution property by using convolution property. So, if I take the corresponding Z transform here, So, there is a convolution in time domain means there is a multiplication of corresponding z transform in the z domain. Okay. Now, if I want to find out what is h of z, that is impulse response of the system, then if you just divide the corresponding z transform of the output and input, you will going to get the transfer function or impulse response of the system. Now, if I take the inverse z transform of this, I will going to get directly. So, that is very easy way to find out the impulse response of the system. Here, if I want to do in time domain, it is a very difficult thing. So, that is why, so if you use the z transform, okay, it is very easy to find out the what is the impulse response or time domain signal or time domain impulse response. So, from this z transform property. Okay. So, now, so if I have the equation which is in terms of the even in terms of the difference or differential equation or in terms of the any impulse response or impulse signals if it is there, or if I know x of n and y of n, then we can able to easily find out what is this transfer function. Now, we can see some problems how if I know the input signal x of n and y of n, how to find out the impulse response, that is finding out the z transform and taking inverse z transform, we will going to get the impulse response of the system in time domain. So, that we will going to see. So, we can take one or two problem how to find out the impulse response of the system. Okay. So, now you can take this one. So, a causal system has the input, a causal system has input x of n and output y of n. Okay. Find the impulse response of the system, find the impulse response of the system if x of n, which is equal to del of n plus 1 by 4 into del of n minus 1 plus minus 1 by 8 into del of n minus 2, and this is x of n, and y of n which will be equal to del of n minus 3 by 4 into del of n minus 1. Now, we know the input and output relation. Now, from this we need to find out the impulse response of the system. So, okay. Now, if you take the corresponding z transform for this both the signals, okay. So, in order to get the solution, first find out the z transform of the both input and output, then you can divide output by input, you will going to get the transfer function, and taking z transform, that is inverse z transform, you will going to get the impulse response equation. Okay. Now, first find out the z transform of the input signal. So, what is the z transform of this? So, if I take the z transform of del of n, it is nothing but 1 plus 1 by 4 into, if I take z transform of del of n minus 1, which will be equal to z power minus 1, and similarly 1 by 8. So, this one z power minus 2. Okay. And we can find out for y of z also, which is equal to 1 minus 3 by 4 into z inverse. So, now we can able to find out what is h of z, which is equal to y of z divided by x of z. So, which is equal to, now we know y of z, which is minus 1 minus 3 by 4 z inverse, and this divided by 1 plus 1 by 4 z inverse minus 1 by 8 z power minus 2. Okay. So, now we can take the roots for this equation. So, how to find out the roots? So, you can see the product is 1 by minus 1 by 8. So, how to get the roots? The product should be minus 1 by 8 and the summation should be equal to 1 by 4. So, like that you have to choose the roots. Now, if I take like 1 by 2 and 1 by 4. So, now we can see 1 by 2 and 1 by 4. If I take the plus 1 by 2 and minus 1 by 4, we can see product will be minus 1 by 8, but the summation will be So again it will be equal to 1 by 4. So that you will going to get. So the roots are plus 1 by 1 minus 1 by 4. Okay. So if I do that one, so we will going to get h of z. So h of z which is equal to 1 minus 3. So 3 by 4 z inverse divided by 1 plus 1 by 4 z inverse minus 1 by 8 z power minus 2. This we can write it as 1 minus 3 by 4 z inverse divided by 1 plus 1 by 2 z inverse minus 1 by 4 z inverse minus 1 by 8 z power minus 2. So we can take the factor, common factor, and we can write it as 1 minus 3 z inverse divided by 1 minus, so 1 by 4 z inverse into 1 plus 1 by 2 z inverse. So this is what the factors we will going to get. Okay. So now again use the partial fraction method and find out the values of a and b. So this will, so we can get that 1 minus 3 z inverse into a into 1 plus 1 by 2 z inverse plus b into 1 minus 1 by 4 z inverse. Now 1 will be equal to a plus,
The 3 by 4, no sir.
yeah, 3 by 4, sorry, 3 by 4 z inverse. Now so the corresponding a and b values will be, so a plus b which is equal to 1, this is one equation, and half a minus 1 by 4 b which is equal to minus 3 by 4. So these are the two equations. Find out the values of a and b. Can you tell what are the values of a and b? A plus b which is equal to 1 and half a minus 1 by 4 b which is equal to minus 3 by 4. Can multiply half here, or you can multiply 1 by 4 better and add it. So this will get cancel each other, and here 1 by 2 plus 1 by 4 times a which is equal to minus 3 by 4 plus 1 by 4. So which is equal to 3 by 4 a which is equal to minus 2 by 4. So this will get cancelled, a equal to minus 2 by 3. Now if a equal to minus 2 by 3, b will be equal to 1 plus 2 by 3, or b equal to 5 by 3. Are you getting the values a and b? Hello. So now these are the values of a and b. Now we can substitute and we can write this expression as h of z, which we can write it as minus 2 by 3 by 1 minus 1 by 4 z inverse plus 5 by 3 divided by 1 by 1 plus 2 z inverse. So now you can take the inverse z transform. So taking inverse z transform, we can get the h of n which is equal to minus 2 by 3 into 1 by 4 power n into u of n plus 5 by 3 into, so minus half power n into u of n. So this is what you will going to get the values. So this we can write it as 1 minus of minus 1 by 2 into z inverse. Can write like that. So minus half power n we can write. Is it understood? Any doubt in this? Hello? Anybody? Got it?
No sir.
Yeah. If you have any questions or queries, you can ask. So this also probably one or two problems practice it will probably it will come. Okay, either it will come Z transform or this time domain analysis. So either of this one problem definitely it will come. Practice is, and you take this problem and try to solve, so and get the answer. So you take this problem and try to solve. I will give and just you try it in your home. So x of n is given it as equal to half power n into u of n minus 1 by 4 power minus 1 by 4 into 1 by 2 power n minus 1 into u of n minus 1. So this is your x of n, and y of n which is given it as 1 by 3 power n into u of n. Now these are the inputs which are given. Find the impulse response h of n. So try to solve this one and get the answer. We will see it tomorrow, this one. So tomorrow there is a test. So this Z transform unit I will give. Okay. So try to practice all the
Sir,
problems.
open the previous page, sir.
Okay. Is this one? A and B, are you getting correct? Hello? Hello? Any doubt?
No, sir.
Are you getting the same thing?
No.
Shashidhar?
Yes, sir, same.
Okay.
Sir,
Yeah.
sir, if you have notes, can you please send?
Notes I already sent, no, in the regular this thing. You don't have that? I have sent, maybe one or two problems are different only, otherwise I have solved the same thing. You can look it once. If you don't have, I will send it again in this group.
Okay,
Sir,
sir.
question bank type stuff, sir, because we can practice more problems. Sir.
Okay, so okay, I will send that probably after the test only. I can able to send for the by the time of the exam. I will send one or three up to at least minimum 3 units. I will going to send first
Sir,
one,
please, sir.
first one, second one, and this set transform possibly. Okay,
Okay, sir.
what are the possible questions? I am not assured that the same thing will come. Type may be similar. Okay.
Sir, this one method you have solved, sir. Another method, power series expansion method.
That I will going to solve. That I will going to solve.
So for test, then power series expansion questions will not be
Yeah.
included.
So power series I won't include, only this partial fraction, and then the time domain, that is time domain analysis, that is transfer function analysis. Okay, that only
Okay,
I will put. So this transfer analysis of LTI system, the transfer function analysis, and then partial fraction I will put. Power series I won't put in the test. Okay.
yes, sir.
Okay, so practice more, and then I think 2 o'clock, or what is the test timing?
11 to 12:30.
Okay, so all of you, I will upload it in the Google Classroom test question paper. So you try to log in.
You have not created a classroom for that uploading fee
Yeah,
receipt, sir.
that I have created like an assignment. You can go and upload it there. So you just see in the Google Classroom, which I have sent the code. You can, using that code you can join. All of you must join today itself. Don't tell tomorrow it is an issue like that. Okay. So by afternoon 4 o'clock or 5 o'clock, all must be there in the Google Classroom. Let me know any issues are there. Okay, I will going to add those who are facing any issues. Is it clear? So the quizzes I will take up later after the test one. Okay, I need to give before the test one, due to some reason I couldn't give it. So I will give that after the test. Study for the test. Will give tomorrow. Okay, is it fine?
Sure.
So any doubts regarding